Let's break down this motor calculation problem step by step. You're preparing for your Colorado Journeyman's exam, and you've encountered a question regarding motor current taking into account efficiency and power factor. The question asks us to determine the current of a 10 horsepower motor operating at 208 volts, single phase with 90% efficiency and an 85% power factor. The multiple choice options given are 46.88 amps, 50 amps, 55 amps, and 68.75 amps. You correctly identified the use of National Electric Code Table 430.248 for finding the full load current and 430.22 for the 125% calculation used for conductor sizing, but you're unsure how to incorporate efficiency and power factor into the calculation. First, we will calculate the full load current directly from the horsepower and voltage using the formula based on National Electrical Code Table 430.248. The full load current equals motor horsepower times 746, divided by the quantity of voltage times power factor. Plugging in the values given, we have 10 horsepower times 746, divided by the quantity of 208 volts times 0.85. This calculates to approximately 46.88 amps. Now, we must consider the efficiency. The motor operates at 90% efficiency, which means only 90% of the electrical power input is converted to mechanical power output. The remaining 10% is lost, primarily as heat. This means we need to determine the actual input power required by the motor to deliver 10 horsepower at its output. To find the input power, we divide the output power by the efficiency. Input power equals output power divided by efficiency. The output power is 10 horsepower times 746, divided by 0.9. This input power calculates to approximately 8,311 watts. Now, we calculate the input current. Using the power formula for single-phase circuits, power equals voltage times current. Therefore, current equals power divided by voltage. The input current equals 8,311 watts divided by 208 volts. This input current calculates to approximately 40 amps. Based on this calculation, the answer is not listed in the provided multiple choice options. The input current of the motor, considering its efficiency and power factor, is approximately 40 amps. It's important to note that the initial calculation using National Electrical Code Table 430.248 only accounts for horsepower and voltage. To account for efficiency and power factor, you must perform the additional steps of calculating input power and then input current as demonstrated above. This is because the motor will draw more current to compensate for losses due to inefficiency and the phase difference between voltage and current caused by the power factor.